Mhm. Hello, can you hear me?
Yeah. Those online can hear me? Okay. Checking the chat already. Okay, let me just check it here. Okay. Okay, yes, we have it on. Yes, okay, that's good.
Okay, so good afternoon once again. So I said my name is Tejumala, and this class is going to be very interactive. We are going to make it as interactive as possible. Okay, and we'll be having a discussion on the classification algorithm. We had one yesterday, that was on the regression. Why this afternoon we'll be looking at the bots. Before that, let's go to introduction and then we'll be good to go. Okay. Okay, so this how to use the Google Classroom. I'm sure you're familiar with it already. I don't need to take us through this. Okay, so the attendance, very, very important. And the attendance is that you attended. Okay, so let us fill the attendance form and use the student ID, not the email. Just check your student ID, use it, and then not the email. Okay, so these are the links that you'll be needing. The record and attendance. So the record is your unique ID, while the attendance is the link, is the form to fill. Okay, and you can also scan the barcode. The barcode will also make it very easy to fill the attendance. Yes, yes, yes. Using the mic. Instead of getting the sound from that place, I'll get the sound directly from here. The way that you can it. Because I already moved cube. Just facing back. I think it's either it make me glass, make it sound the eruption. Okay. Okay, so okay. You need to complete the assessment. At least 80% of the assessment needs to be completed, and at least six out of the eight live sessions must be attended to qualify for the badge. Okay. Okay. This one will be needed for this technical session. The Colab Anaconda that also contains Jupyter that we can use. So Colab is online, and then if you need to go online, there is free Wi-Fi here for us on site that we can just connect to use Colab. So this just it. If you are not yet connected, you can just connect to it now for us to have a smooth class. Okay. The audio is not clear. I can't hear. Okay, we are working on it. You can also hear that. Perhaps someone should just respond that we are working on it. The audio will soon be okay. Thank you very much for that. Okay. So these are very important links for us that we need to. Okay, you can see from here. That's available. Okay, so let's start the class. You don't have it. Have you checked the class? It's not there. Okay, so let me just display the link so that you can just get it from the link. Okay, so this is the data. This to get data set, can we use this link? bit.ly/AI. Yes, data 2. Okay, so that's the link to get data set, and then this is the Google Colab where the notebooks are. Okay, let me now share my screen. Okay, so do we now have access to the uh, we don't have access to the data? Okay, let me hear this. Can you paste the link here? Okay, let me try doing that. So let us start. So what do we understand by classification? I'm sure we know it already. I just want to confirm. So classification model, classification tags. What do we know? Okay, can we just talk to that? Let's speak to it. Anyone online on site? Okay, classification. Okay, what do you mean by that? What do you think that means? That you work if you are working on the classification tax. Okay, so we can actually just explain what the classification model is in machine learning. We study. Hello, anyone online? Can you hear me? So, okay, the output is this photo. Thank you very much. Yeah, the output is this photo. It's header yes or no. It's header one or zero. It's header. I can give you a classification tax. The first, not the fourth. It's either purchased, not purchased. Okay, binary, you also have multi classifications. Okay, but that, thank you very much, Julie, for that. I don't know, you're not hearing very well. Can't hear you well. Can you hear me? Can you hear me now? Hello? Yes, you can hear me. It's better, right? Okay, it's better without the mic then. Okay, so I will have to shout. Okay, so Okay, so let's just start this. Okay, good. Okay. So supervised learning classification. So today we'll be introduced to classification algorithms. Also, we distinguish, then we know the different type of classification based on class. These are the types of classification algorithm. Use a classification algorithm using scikit-learn, and then evaluation of classification model performance. So we have examples of classification tasks. Examples are spam detection. Is this spam? Is this mail is spam or not? Coach prediction. Will this customer continue with us or not? Sentiment analysis. Is this a good one or bad? What's it now? Sentence. Dog breed detection. Is this bingo or what? Or Rottweiler? Okay, so that's just it. That's just the basis. So classification is a subcategory of supervised learning, as we already know. Okay, so we also have other categories, right? Like what we learned yesterday, regression. Yes, regression is also a subcategory of supervised learning method where data points are grouped into classes as outputs using a decision boundary to separate each class. I mean, now to separate each class, as you can see on the screen, this is how it works. There is always a line, a boundary, a decision boundary that separates it. So class A, class B. So class A can be uh, purchased, while class B can be not purchased. Class A can be one, while class B is what? Zero. So there's the decision boundaries is always drawn, and this is what actually classifies these data points. Okay, so we have type of classification tags. We have the binary classification. That's two. When you hear binary, that's two, right? Okay. For example, the spam, not spam, biometric identification. Is this the person? No. Is this yes or no? Okay. And we also have the multi-class classification. We have the digit recognition, where classes can go from 0 to 9, predicting a party that wins an election. You know, we have those parties already. Just want to know the one that will win the election. So we have a specific number of parties. Are you getting it? For example, in Nigeria now, we have PDP, APC, and other parties around 70 or up to 70, right? Parties. Okay, so it's multiple, but we have them. We know that these are the. It's not continuous. They are not continuous. Okay. Uh, So we have types of classification algorithms. So these are different types of algorithms that we can use for our classification model. We have the logistic regression, naive Bayes classifier, nearest neighbor, support vector machines, decision trees, boosted trees, random forest. Now, I won't be talking much to the algorithm this time because of our time. Okay, and then we still have a long way to go based on our objective. And so, but each of these algorithms have their biases. They have their instincts. You know, they are just like the brain that we give to the machine to learn with. So they will always learn according to their what's it like their view. Are you getting it? Are we on the same? Are we on the same? Are we on the same? Are we together? Are we together, right? So you need to understand the data to actually know the algorithm that you should be using. Hmm? Getting it? So you need to understand the data very well. So how classification works. So while regression algorithm can be used to solve regression problems such as this, classification algorithm can be used to solve problems such as this. Okay. Other classical real world example are this. Okay, so customer behavior prediction. I'm just making it very
Although
fast
you have
so that we can actually cover a lot. Customer behavior prediction. Customer can be classified in different categories based on their buying patterns, web store browsing patterns,
stop doing
so
something
Jumia,
like a personal
Amazon, they use
not on a
this
contract job.
prediction in insurance
I think
if
it's
a particular customer will get an insurance
supposed to be
or
like
not. So these are real life examples that. So I would like someone to just give me more examples that we can use real world examples that we can use this classification that we can use a classification model for. Anyone apart from the one listed here, from your understanding of classification model. So what are those things? Those are those problems that we can actually use classification model. Yes, that you can also use. It can categorize as a classification task. Online too, if you have a response, I'll be glad. Okay. Yes, cancer or not, yes. Yes, the level we can even use to know the level of growth of the cells. That's good. Yes, right. Another person? Huh? Web weather prediction. How? Sunny rainy, okay. That's that. Uh, yes, that it can be that it can be possible. He already has the label. Now let me ask this question. If you want to predict colors, is it a regression tax or a classification tax? Who is against? If you're against it, let me see your hand. Want to predict colors? Yes. Is it a regression tax or a classification tax? Color, yeah. If you are for regression, your hands up. With explanation, no. No, you are going to with explanation. If it is regression, your hands up. If we don't explain yet. If it is regression, if you are if it's regression, oh classification, people online are saying classification. Okay, no problem. If it is regression, your hands up. Only you. I ask you up your hand. Okay, all of us classification, right? Except okay, so yeah, let us know why is regression. Which one you? Which one? Okay, so okay, okay. I don't know why ladies are not even talking here. You know that there are different kind of colors now. Can you know all colors? We have pepper red. We have different shades. But now, if you are restricting it to the primary colors, it can be classification. But if you are going to colors generally, it's actually regression because we're using the hexadecimal or the RGBs. I know if it's number, then it's what? Infinite, it is continuous. Okay? Are you sure? Are you sure? They are very different though. Yeah. Okay. Now, no, no. I would have loved us to even go online and see it ourselves, but because of our time, let us pause here, and then after the class, we continue with the discussion. I think that's cool. Okay, so it can either be a classification or what a regression task, depending on our target. If you are looking at the primary colors, good. And then if you are actually looking at colors, all the colors that is definitely going to be a what? A regression task. Okay, so let us look at the difference, right? Between classification and regression. Classification, regression. Can we see this image? Can we see? Okay, so who can just use this image to explain to us what are the difference? Classification, regression. The first one is classification. And it's there now, it's written now. I just explained. I have done it with the first one. It's both. It's written, both written now. Classification, regression. You have not explained. Okay, yeah, yeah. Okay, explain. I know you can explain. Oh, yeah. Okay. Good. One, 1 to 100. That's good. That's good. 1 to 100. Okay, so can I have 0%? And we can have 55 points. Okay. Okay, so that's good. Okay, anyone online? Okay, sure, you cannot unmute. Sorry, I will have asked someone to unmute and just tell us and just explain to us online. But I hope you are following. Okay, so yeah, as we explained by your name. Hello, your name. Aduragbemi, as explained by Aduragbemi, it's obvious, pass or fail, and then the second one is what percentage. So because percentage can be from 0 to is very large, and so we look into that. That's a regression task, and then why the classification task is what is pass or fail. The first diagram is either pass or you fail. So it depends on what you actually want to predict. If you actually want to predict it strictly, that I want to know if the student pass or fail, or yes. Oh, okay. I don't know. I think there's a solution on that already, right? That by just taking, it's not even positive. It's just by taking the picture, it tells you the level of growth. It shows now they have, I know there are class, no medicals, that there are, they have been categorized. Those levels have been categorized. They're not in number. They have been categorized to, I don't even know, why primary, secondary, or something like that. Okay. So by taking the picture, it actually tells you, it predicts that this is in the text. That so I think that's another question. There are two. Yes, yes. A solution for is the level of cataract growth. Yes. So you can there are a lot of solutions online. So okay, I think we are good to go with that. Let's continue. So these are the differences tabularized. Uh, the properties, that's the output. One is regression is continuous. Allocation is what's discrete. Learning function, the line of best fit. For classification, it is decision boundary. Evaluation metrics, we have the mean square error for regression, mean absolute error for regression, root mean square error for regression. While for classification, you have accuracy F1 score, failure under the curve. Want to take the picture? Okay, but you have the slide. You have access to the slide. You will have access to it. Okay, yes, but you will. But you will. Yeah, you will. Okay, so this is logistic regression. In logistic regression, one performs a linear regression but applies a sigmoid function for the outcome. So these are the looks like, okay, sigmoid or logistic regression. So it's similar to it. Okay, so this is it. It's similar to linear regression, but uses this function, the signal function, to what for the outcome. So the statistical was this now formula behind this. Okay, yeah, this is it. For you that needs it, so that's the statistical formula, and then this is the sigmoid. You know how to calculate it. By using all of this function, definitely we get this. That's mathematics for you. And this is how it does it to produce the outcome. Okay, so let's look at some advantages. The regression algorithm is easy to implement without high compute power and very easy to interpret. It does not require feature scaling and provides a probability score for observation. So these are the regression algorithm. It's very easy to implement. It's just like linear regression for regression tasks. So you can always start with it. Very, very easy. You can use it as a baseline algorithm. Does not require feature scaling and provides the probability score for observation. So let's look at some of its disadvantages. It is unable to handle a large number of category features slash variable. Okay, it is vulnerable to overfitting. Okay, it's vulnerable to overfitting. Is what's overfitting? You know what overfitting is? What's overfitting? It is is more than I too know something like that. Yes, yes. So the outperform, it will perform very well. You do I too know, when you think you know much. Okay, so that's overfitting. One other fitting is what? But you actually know some. Okay. Okay, so let's quickly go to the notebook. Uh, as we go practical with what we have been learning. Any question before we do that? Online, any question? Do you have any question? Okay. Overestimation, underestimation. Good. Thank you, Ife. Oluwa, thank you very much. Okay. So any question? No question. Okay. Any question? No question. But I can ask question. But I'm sure we know it now. Let's move forward. Let's move forward. Okay. So we have a question here that we want to solve a task. You are not a data scientist in an organization, and you have been given this task to work on. So who will read it? Okay, let me read it. Let me read it so that for those online. You work as an analyst in the marketing department of a company that provides various medical insurance in Nigeria. The manager is unhappy with the low sales volume of a specific kind of insurance. The data engineers provides you with a sample data set of those that visit the company's website for medical insurance. So the data set contains the following column: user ID, gender, age, salary, purchase. So the purchase here is an indicator of whether the user purchased, that's positive, or not purchased, that's negative. A particular what, a particular product. As you must have guessed, this is a binary classification problem with the positive class being purchased and the negative class being not purchased. So as an analyst, a data scientist working for this, okay, working for this organization, we want to solve a problem. So how do we solve it? How do we solve it? And that's why we are here. So let's solve it together. Launch your collab. Let's start now. You have, I think okay, you have logical. Okay, load your data sets. Have you imported all the libraries that will be needed? You need to import. Uh, you need to import. Sorry. Uh, we need to import. So let us import NumPy. Let's import pandas. Let's import matplotlib. Let's import Seaborn. Let's import pandas profiling. If you are using Colab, uh, let's install pandas profiling first by using pip. Okay, to do that. Okay. Okay, so can we load our data? Do you have any issue importing? Okay, those online. Are we together? Are we together? If you are still with us here, can you just drop? Okay, good. Thank you, Abraham. Thank you, Trust. Thank you, Christina. Thank you, Festus, Celine. Thank you very much. We are together. Good. Tomiwa, Adeyemi, thank you. Okay, so have we all installed the necessary libraries, NumPy, Pandas, Matplotlib for our graphs, for our visuals, Seaborn also for our graphs, for Pandas for our descriptive analysis, exploratory analysis. Have we ordered that? Jupyter. Are you using Jupyter? Then use it. You can just import it. Let's start by importing NumPy as NP. You already have this, right? Okay, OS. I want to be sure we are all on the same page before I continue. Because we want to solve a problem. This problem is making the manager unhappy. And we need to solve this problem. Okay? This URL. Do you have the data? No, you're not common for you to use the URL. But if you need the URL, let me just give you. Can it actually function for you guys? Yes, you can always get the material from your Google Classroom. Yes, you can get the material from the Google Classroom. Patrick, so you get it from the Google Classroom. So the first thing is for us to load our data. Okay, that's what we did. Okay, the modules to import NumPy, Pandas, Matplotlib, Seaborn, and Pandas profiling. We can't find what? Is it Pandas profiling? Are we having any error? What? Which one? You need to install it on Jupyter. Yes, on Colab. You need to follow. You need to import it. For only Pandas profiling, please import. Do this pip dot install pandas. I think it should be pip dot install pandas profiling, right? Please can you just check the documentation so that pip dot install pandas profiling. That's for underscore what? Profiling, yeah, that's it. So for collab, it should be pip install pandas underscore profiling. Yeah. Okay, online, have you all imported the necessary libraries? Okay, thank you, Tony. Yes, you need no, you don't need to install pandas. Uh, you don't need to install it. That it should be installed already on Anaconda and Trust Oyewole. So you just need to import it. Pandas and NumPy comes with Anaconda. Thank you. Okay, Samuel. Okay. Oof. So now we want to know. Want to know how our data looks like. Want to know our data looks like. So we want to see the first five. Okay, the first five row, including the heading. So that's why we use that insurance dot ahead. Now, insurance is equals to insurance is a variable here. Uh, Pandas that's PD. We use this line of code to actually read our data. So the data stored in this URL. So pandas dot read CSV then URL. So we use it to read, and then we use dot head to actually print out the first five columns. Now we can change it. We can change the number of columns that we want to print out. You can change it to 10, but the default is 5. That's why the 5 was printed here. Now I have the first 5 columns printed here. Now let us see what our data contains. So the user ID, the gender, the age, the estimated salary, and the purchase. And then don't forget that our purchase is our what? Hello? Our purchased here is our target. So we want to actually learn. Okay, thank you very much, first of all. So purchase here is our target. Thank you very much, all of you. Yeah, okay, good. Thank you. So purchase here is our what? Is our target. So we want to predict purchase. Now, as I've earlier stated, I said that the default is 5, but we can actually change it to. So let me run this. I've not done that. Let me run it so that I can also. Look at this guy again. Come on. I should have committed this. Okay. Okay. Don't mind me. I had to stop this installation. Pandas and I'm going to install this now. Let me run it again. I think we are good to go. Okay, so we now change the parameter to 2 for the head, and now we can just have we should have 2 column printed as so. 2 column. So we can also change it to 100. We can change it to 10. We can change it to 20. For example, I just changed this to 10, and then to print the first 10 column. I mean the first 10 rows. Purchased, not purchased, and then okay. We can also print the tail. That's the last rows. Let me see if let me just what should I do this? Yes. So the table will give us the last five for default. So we can also change it to the last 10 or the last yeah, depending on what we want. Okay. So after doing that, we now know how what's now how our data looks like. Now there are some now we need to go to the data cleaning part. There are some columns, some features that we don't actually need that can actually disrupt our the machine learning model. So we need to drop them. Most of the time, unique ID or user ID uh, uh, we always be dropped because we don't have effect, or the effect may even be negative on our model. So this is why we are using the drop function here to drop what? To drop the user ID. Are we together? So we're actually dropping the user ID. We specify that it is a column, and then that in place is true. That we should not, you should remove it totally. Good. And then after printing the insurance variable again, then user ID has been removed permanently. Are we good to go? Are we together? Are you sure? Are you writing it on your own? Okay, if you are not writing it on your own, can I see your hands up? Okay. If you are not writing the code on your own, let me see your hands up. If you are writing it on your own, let me see your hands up. You are writing it, you are writing it. Okay. Who else is writing? Are you following us? Like, okay, online, are you writing it? Are you also okay? We are writing. Okay, okay, good. Uh Adeyemi asked me to explain what part. Okay, good. So are we together? Samuel John, I'm writing, but I've gotten code. Okay, Samuel, where is the problem? Where do you get the error? Okay. Okay, I should explain the code. Which part? What part? Yes, finance profiling. Okay. Okay, Samuel, are you using Jupyter? Okay, probably that's why. There are some requirements that may not be met while installing pandas profiling on Jupyter. So it's always cause issue. It's always cause issue. Yeah. Yeah. No, it won't work. It won't work. You did what? And that's good. Collab is different. It's not always like that. Because I personally do have problem using final profiling on Jupyter. So if I actually want to work with final profiling, I just come to Collab and install it and I use it successfully. It brings an error of requirements, something like that. It brings an error like that. So in place to actually remove it totally. Are you getting it? Ellen. So it removes it. If that wasn't done, it will still be there. You know, we didn't save it in a variable. I get it. So we didn't save this in a variable. So it will still be there if you do not put that parameter. Thank you very much, Ellen. Okay, so let's continue. Okay, so we have dropped the user ID, and then there are some things that you need to check. You need to check the description. You want to know the data analysis everywhere. It's just the tools are different. The concept is the same. You need to be sure if the data types are correct. You need to be sure if they are not missing cells, missing values. You need to be sure. Not again, not again, not again. Yes, you need to be sure that everything is in order. You need to be sure that everything is in order. Okay, that's what we do when you clean the data. And then afterwards, modeling is just very easy. You just call it and then you get it done. And another part that is very important is the explanatory data analysis. Now, when you are exploring the data, it's actually for your own understanding. Okay, it's different from uh, what's this now? What do we call the other one? Explanatory, right? Yeah. We have exploratory and we have explanatory. Yeah. Something like that. Yeah. So this is what you do. The second one, explanatory, is what you give to your customer, I mean your client. Are you getting it? Why the explanatory is for your own consumption to understand the data. Hope I'm not confusing you. Okay, thank you very much. So let's continue. Exploratory explan. Okay, we trust. Thank you. Okay, so the insurance. So we have successfully dropped. Okay, if you're in the SQL class, drop is drop, Abi. Okay, good. Okay. So now we want to map, because for us to model correctly, especially with the algorithm we are using, it need to be our target needs to be an integer, and that is what we are mapping. Okay, so we are just representing purchased with zero, and representing purchased with one, and not purchased with zero. With that simple code, lambda, yes, that lambda function, uh, insurance purchased is equals to insurance purchase dot apply lambda x one if x is equals to purchase. So if x is purchased, represent it with one. S is zero. So if it's not purchased, it's zero. So let's assume we have other values like the purchase. It should also represent it as what? As zero with this code. Are we together? Okay. So that was just it. To represent purchased with one and not purchased with one. So are we good to go? Are you writing? You are not. Moderators, you came late. Why is not writing? Why is not writing the code? Why is not writing the code? Online, who is not writing the code? I want to know. Who is not writing? You cannot raise up your hand, they are not writing. Why? Okay, let's continue. What is very, very important for you. When you write it, it's interesting. When you are not writing, you are listening to a lecture or a speech. Okay. So it's more interactive when you are writing. Okay, so we now print the head again to know what our data actually contains. We have successfully what? Uh, Mapped our purchased with one and what not purchased with zero. Let us check the page. I think this okay, this is it. So the head, can you see now? One is purchased, that's the female, that row number 7, female purchased, while others are not purchased. Good. Huh? Yeah, they are typing. Hey, they are typing. I said, okay, okay, yeah. Let us just make it fast. Let us make it snappy. Let's make it snappy so that we can finish this on time. And this notebook will be shared with you. The notebook will be shared. It will be shared now online. The notebook will be shared. Just believe. It will be shared. Just check your Google Classroom. Probably it will be shared. 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 Yeah. Even it has already been shared. Come on, check your classroom. Close, check your classroom. Yeah, it has already been shared. You see now? Okay, the slides are that we settle that one later. But the notebook that we're working with has already been shared. Just let's check our classroom. Let's check the classroom, please, so that we can make this thing. We can do this thing and then finish at normal time, appropriate time. Good. So okay, so to get the information, so we use the function info to get the information. Now, this shows us that gender is an object, while age is an integer, salary, estimated salary is also an integer, purchase because we have actually mapped it is now what? An integer. Okay. Now let's use the pandas profiling to carry out the exploratory data analysis. So to do that, pandas profile report insurance, and then not a step due to USL. happens like that. Okay, so this is the overview. Number of variables. Don't forget that we have four variables there. The age, the gender, estimated salary, and purchased. Good. So that's it. And then this is it. We have two numeric, one categorical, one boolean, no dates, no tests, rejected, unsupported, none. So the variables, how many female? We have 204 female. So we have 196. Now imagine without primary program, you'll be writing each code. You're writing the code to produce this. The code to produce to give us this bar chart for female. For this gender, we write for so especially the panel program actually makes it very easy. It just brings everything together at once and you can just understand your data at a glance. That's just it. Okay. These print counts, these are the unique value that we have only two. This for female frequency count. For age, distinct count we have 43, mean 10%. This is the mean age, this is the minimum, and this is the maximum. Okay. So these are the minimum, fifth percentile, Q1, median, Q3, 95th percentile maximum range. Security statistics is the standard deviation for age. It's very interesting, right? Good. And then we continue like that. We also did the same thing for estimated salary. Okay, listing count 117, mean, maximum, the minimum 150,000, the maximum, sorry, the minimum is what 15,000, while the maximum salary is what 150,000. Okay, so that's how it is. And then this is the correlation. What's the correlation between age? Let me bring this back. Okay. 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 So this is the correlation between age and age and age. Okay. They are correlated. That's why we have the red. Okay. Between estimated salary and age, they are okay. This it's around this area, right? So the correlation is somehow low. Okay, purchased and age, the correlation is higher than for estimated salary. And same with these two age for estimated salary and so on and so forth. So I think you understand this chart, right? You understand this chart? You understand? She's only one I responding. Do you understand this chart? Do you know the implication of this chart? Do you know the implication? No. You know the implication. Can you just tell us? So if they are related, what do you do? You only need one. So if two variables are highly correlated, it means they are the same, they have the same effect. So we can drop one of it and then use the other one. But if they are not correlated, then it means that what we can actually what contribute to the model that we are building. So let's continue. You think what? Okay. Issue. But logically, let's look at it logically. Yeah, yes, now. Yes, I wanted to. If hello. So, you want to test the contribution model. I'm getting it. And we are contributing the same thing. If you are contributing the same thing, not that your collaboration, you coming together, will bring a better result or a higher result. It's only complementary, or no, it's substitutional. You can actually substitute. Whether you use this or you use this, since it is the same. Yes. Okay. We try as much as possible to reduce the number of features. And this makes it very easy. So this is a count plot. Okay. Yeah, he's talking to us. Yes, talking a lot of. He's saying a lot of things. Can you see? He shows us the correlation, to know how correlated these guys are, the features are. It shows us the standard deviation, the unique counts, distinct counts. This for purchase now. Let's take purchase for example. Distinct counts, we have 1 and 0, right? But this is the mean. We have 257 counts for 0, while we have 143 for 1. So purchased, we have this observation for purchased, and we have this observation for not purchased. I see talking to us. Speaking to us. So let's continue. Finance profiling. Finance profiling just brings everything together. Yeah. The words. Yes, 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 yes. Yeah, I think it's also here. Let me see. Okay, it's not here, right? Okay, so look at it. Yeah. Are you referring to this? Oh, that's VS Code
In that
advantage.
toilet, what are the combating serum instead of the flood?
Overview, okay.
When in another side of
Okay, so let's continue. Okay, so this is we are using Seaborn to plot a count plot for purchased, and as we can see, this is a result. This is a visuals 0 and 1. Now these have been given to us by the by pandas, using pandas profiling. Okay, so we can see that the majority of those that visit the medical insurance company is not want to buy the insurance. So this is an example of class imbalance. That is, there is no equal proportion of those that will buy or not. So imbalance can also uh, affect the model we are building, and so we also need to what to cater for imbalance. I'm rushing. You have to rush because according to the time, I only have 7 minutes. Yeah, 7 minutes. It's interesting, right? Okay, but thank God we now have the notes, so we can always go to the notes. Yes, you have the notes. So we can just go to okay. So this is another plot to show the function of male and then but those the maid are purchased and the maid are so we are using gender, we are using purchased. So how many maid purchased, how many female purchased, how many maid did not purchased, how many, so we actually want to understand that, and so that's why we did this. So this shows that let's purchase, so we purchased this one, this color. So male, I think we have more female that purchased than male. And then we okay, yes, we have more female that purchased than male. So this is a box plot. The box plot actually shows us the mean, the maximum, the minimum, and the outlier. So this is the outlier. So this was plotted by the using the age and then and purchased. So the age and purchase was used. So the age is on the y-axis, while purchase is on the what, x-axis. So we are usually using this age. So this shows that those that purchased. Okay, let me see. So this is the medium, this is the mean, right? Why this is the maximum, and then this is the minimum. This is the outlier. Okay, let's continue so that we won't be wasting much of our time on that. So this is another one for estimated salary. You want to know the salaries of those that purchase. Those that purchase around this area. So those are those people, the people that are collecting 80,000 and above. Okay, the average at that's around 90,000. So those that collect 90,000, as that's logical enough, you can actually what's it now? They have more money, so they can go in for an insurance. So now let's go to the model building. So people that earn higher salary purchase the insurance. Why those, that's just the capitation of the box plot I just showed. Why those that earn low did not purchase the insurance? Let me see what is going on in the charts. Okay. Sorry. Let me see that. Hello. Let me see. Imbalance. Okay, Ellie asked me to explain imbalance. What does hue means? Hue means, and isn't that color? Okay. Okay. So imbalance means we use a data set is imbalance when we have um, a category. When a category is more than the other, especially the target variable. So if you have, for example, the one we have here is what is imbalance because we have more of those, a lot. No, the difference is clear between those that was purchased and those that did not purchase. So that shows an imbalance. Okay, so the hue here actually is to you can just uh, call it legend. Are you getting it? Can just call it legend. Just for your understanding, legends, you know what legends are, right? Huh? I should know what it is. You don't have the note now. Download it and work with it. You can see it. So, what again? Yes, Juni, box plot is actually a visual that you can also use to understand your data. But yeah, well, we get to understand it late. We are running out of time. I just don't want to talk much on that. It shows the mean, it shows the maximum, box plot shows the minimum, and then what is it? It shows the outlier. It shows the outlier. So them just let's take that as a summary of what's used for. How is the legend? How is the legend equals? I don't get that, Ellie. I do not get that. I don't. Can you please rephrase your question, Ellie? Okay, thank you very much. Please, okay. Ellie, please kindly rephrase that your question. How is legend equals to purchased? Oh, no, no, it's not that legend is equals to purchased. Hmm? Now, now look at this count plus this count plot. We only have a variable, that's the gender. Now check the second count plot. We now have two variables. We are using gender, we are using purchased. Get it? Yeah, Ellen. Okay, so let me continue. You have an idea, good. Okay, so we can just let's just continue with this with the class, and other questions I will respond to them later. So let's go to model building. So as in the objective, we'll be using sklearn. Um, it's an ML library. It's an ML library written in pandas, written with Python code. So we'll be using it to build the model. Now we are done with the explanatory. We have done some. Have you done any cleaning? Yes. Okay. Yes. We have done some cleaning. Okay. We have mapped this. Now let's build the model. Now let's build the model. Let's build the model. Hello. What's your name? Oh no. Okay. Hi. Hello. What's your name? Anoma. Okay. Anoma. Your name? I choose it. I want to know those that are making noise in the class. Okay. That's not going like that. Okay, so let's just continue with the video. I'm not making noise. Okay, so let's just concentrate and let's just get this done once and for all. Okay, so we are using scikit-learn, and then we'll be importing our algorithm from sklearn. So first we need to import our metrics. So we'll be using the metrics to evaluate the model, and then we'll be selecting. Uh, so we are. So let's quickly do this. Let us from sklearn let's import metrics for evaluation, and then for splitting our data sets into the train and test. Let us also from sklearn.model selection, let us import train test split. Now, you know why we need to evaluate. Now, the reason we need to split you know why we need to split the data set? So that we can evaluate. So because if you don't split it, you cannot evaluate. Yes, now. Now this is it. We have this. So the train one. So you train your model with a part of it. Then you believe your model has learned. Now the test that you also know the answer. You now use to test. So if the answer there are not discrepancies in the answer, then you can now know that I think I need to train my model more, and that's what we are going to be getting our metrics from. Okay, so we need to drop we need our x and we need our y. So our x is the what? Is the features that we'll be training with. Why the y is what? Is the label. So to get x, you subtract y. from the later set. So that what we just did for x. For that first that x equals to insurance the drop purchase as column. Dropping purchase, that what we did. Okay, because we needed x. Are we together? Hmm? Aluma, are we together? Okay, I think we need to. Okay, so y is purchased while our x is what? So we can print y. Okay, after printing y, can we see the head? The head for that's just 000. So one column. So our y is now a single column, which is for purchased. Are we together? Yeah, thank you, Felua. Okay, validation of result after testing. Thank you. You cannot see the screen. You cannot see my screen. Can you see it now? Hello, can you see the screen now? Okay, thank you. Good. Okay. So as discussed previously, we need to create a one hot encoding for all the categorical features in the data because some algorithm cannot work with categorical data directly. They require, huh? You can use lambda. You can use lambda. But get dummies, we just do it automatically. Get dummy as all the categorical data there you work on. Yeah, if yes, you can use your yes, you just get it done. And you can also use lambda. Since it is gender, that is female and male. I get it. We just let female be one and let female be one and then male be what zero. Or let male be one, let female be zero. Okay. And so by using get dummy, pd.get dummy uh, for gender, then we get this something like this. So female. So if it is not female, it is what zero. If it is female, it is what male. If it is female, it is zero. So we now have two columns instead of one column that we clearly have for gender. We now have two. It is male and female. So if it is female, it is one under female column. Okay, and then if it is male under female column, it is zero. While if it is male under male column, it is one. Do you understand? Do you understand? I have a question. Ladies first. Thank you. Okay, no problem. It's wait. That what? Yes. Yeah. Actually, a duplicate. Technically. Technically, it's a duplicate because if it's not one, it is zero. Also, we have two values there. We have zero and we have one. Are you getting it? So we can actually drop one. But that may not be necessary because you know it is female. Okay, only if you change the column name again. But that would be necessary. But with this, it's actually the same. Yeah, it will create. Yes. It will yes. It will create those two columns. It can be more than two. If you have more than one, yes, more than one category. For example, it is blue, green, yellow. You do it. Yes, just do it. Get them, just get it. Yes. Yeah, it will. X is the factor. Yes. So we have independent and dependent, right? Independent variable and dependent variable. So why is our what? Dependent. Why the x is the what? Independent variable. Okay. So the y depends on the x. Are we together? Hope I'm not confusing us. Okay, good. Thank you. Thank you. Are we enjoying the class? It's good, right? Okay. Good, good. Okay, so you want to get, so to know, to get the information, okay, so this is to get more information about X. And now age, before it was an object, but now is it age? No, gender was an object before, right? Okay, gender now is now what, a unit, unit. I think that's integer also because we used get them, so that's why it is unit. Okay, good. So split data into training and test sets. So that's what we'll be doing now. As discussed, we'll be splitting our data set into future, which is X, and label, which is Y, into training and test data by using the train test split function from sklearn. The training set will be 80%, while the test set will be 20%. Because we need a lot of data to learn with. Yes, you need a lot of data to learn with. That's why the training is more than the test. So you want to learn with more data. Okay, and the random state that is set to is 1, 2, 3. We use 1, 2, 3 for a random state. Is for all of us to have the same set of data. Now, so this is to split. Yes, 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 yes. Okay, let me. Which one should I change? Okay, let me change this one to 42. How? Am I not changing it? Where is it? This is the view, right? Let me. Okay, thank you. Okay, good. So now the reason for the random state is so that we can have more the same results. Because if we don't do that, we all be getting different. We are splitting, and we're splitting them at random. So how are we sure? So if we don't use the same random state, what will be selected? The observation that will be selected for yours will be different from what will be selected for my own, which ultimately make our what's it now? Our model different. But if you have the same random state, then to select the same observation, and then which will also give us a uniform accuracy and model. Okay, good. So we are using logistic regression. So we have splitted it now. Okay, so these are the parameters: train, test, split, S train, Y test, X train, S test, Y train, Y test equals to train test split. X, that's our X, that's our feature, Y, that's our target. Test size, we said it is what? 80%, right? So our test size is 0.2, right? 20%. Good. So our train size will be 80. So that because our test size is what? 20%. So our random state is what? 42. So we now need to import our model. Okay, from linear model, we are importing logistic regression. Okay, there are others that we can use, right? As I've previously highlighted. Can we mention them? Aha. Hey. Yes, now other model. When you said ha, it's like the way he says sa, like he goes with precision tree, random forest, S, uh, K nearest neighbor, what again? SBMI. Okay. We also have the boost, right? The SG boost, right? Okay. No, we can use any. I just Okay, let us for this one. Let us use another. Oh, yeah, suggest. No, no, no. Not necessarily. Suggest. Let's use seven. Seven. Let's use seven. Let's use it. Yeah, Shabi, I don't know. You use seven now. Use seven. It's interesting. Let's use seven. Okay, so I've not been loading this. Let me see the necessary part I need to so that I need to run so that we can have a ba. Don't need this. Okay, okay. Mm, you know, uh, Candace profile we actually work on the color, each color. But there are situations where you want to compare two colors. Or what we did to purchase and gender. Final price did not show us that. So there are also other questions that we need to answer that probably will not just give us. So final is just a basis foundation. It just help us get make life easy. In fact, do you know for ML you can even you may not even write any code. You just drag and drop. Yes, you have drag and drop solution for machine learning. We have nine. We have what again? Microsoft Azure. Azure, yeah. So, every yeah, something will change. Now the random state is we are splitting it. We have a data set and want to split it. It will select them at random to train and to test. So setting the same random state will ensure that it's selecting the same observation for you and me for test and train so that we can get the same results. But if you don't do that, you set another random state, then to give me, I will get another result, you get another result. All of us can get can better, can worse. I don't know. I don't know. Yes, I don't know. Okay, okay. I think I've done this. I don't need this now. Okay, so let's continue. Okay, let me do this. Are we together? Are we enjoying the class? Hey, I know something has not happened. Not, okay, let me do this. Okay, okay. Good. So, oh, so as discussed previously, we need to create one noted. We have done that now. Okay, so okay, so nothing. Oh, this one is still doing And this is the reason I don't want to. I initially don't want to stop myself loading the notebook because of issues. Okay. This, what is this? What is this? Ah, what is this? So sorry. Let me just run. Okay. Okay, so we have splitted it, right? You're welcome back to class. Hello. Okay, are we still together? Sorry for collab, some issues like that. It happens. Happens. Okay, so we are using logistic regression, and now we have imported our model, Now we have a instantiated model. So that's what we did by doing this, by instantiating the model. So we can call it, we are keeping it in a variable. Yeah. So we are keeping in a variable logistic model. So this is actually the model and we are keeping it here. So there are parameters that we can also put here, actually to tone our. Hey, we have 7 more minutes, so let's be fast. So this is where we fit. This is where we fit our model. We see the X train and the Y train. Okay, and then this is where we do the prediction with the test. The test. Can you see it now? Can everybody look up? Are we together? Those online, are we together? Okay, those online, are we together? Okay, yes. So this is just it. Let me quickly explain this code. We instantiated this model. Now we use the model to fit our train, our S train, and our S and our Y train. We just trained it. So this is the training of the model. This code is actually the code that trained the model. I'm getting it. By fitting it means that we are what? We are using this algorithm to train our machine with this data. Are we together? Are we together? Okay, good. So this is where the prediction comes in. Now we are now predicting with our S test. So we are predicting with our S test with the model that we have used. Don't forget that the name of the model we built is what? Logistic model. This model. So we are now using this model to predict. Now let us now evaluate our model. Since we know the true label in the test set, this, okay. Hence, let's evaluate. So now we'll be using the confusion matrix. So confusion matrix can be used. So this line of codes are just to not to confuse us. Now, in fact, the confusion has not yet come. Okay, that's in the lighter mood. The confusion has not yet come. When the confusion come, I will let you know. Okay, so the confusion actually comes here. Now, all of this code are just to format this confusion, this matrix, confusion matrix. Okay, no, where you just use the what's this now? The plot lib, the matplotlib that we imported initially. We used it to label it, predicted, and then the font size of this is 13. Okay, the X label, that's the X axis. Okay, we formatted it this way. The Y axis formatted it where this is the X label is predicted, why the Y label is truth. So the title of this of the visual is called a confusion matrix. So this is a confusion matrix. What actually generated this is this code. Okay, so let's continue. Now, okay. From sklearn, don't forget we imported this, and now this is the code that actually gave us this the matrix. So CM is equals to confusion matrix Y text and Y print. So Y test is the test, the answer we know that we kept. While the Y print is the prediction that the machine just made with the S test. Are we together? This part is very, very important. You need to understand it. This is where the okay. Y test. We split we split to test and train. Okay, and then we for X, I mean for train, we have X and Y. For test, we also have X and Y. You know that our Y is our target. Okay, for train and for what? For text is our target, right? So we have built a model. We trained it with our with the S train and the Y train. Now the model that we have built, we now tested it with S test. Now the model now gave us some prediction. The prediction is now widespread. You can name it anything. No, widespread. Now we now want to compare the test that we kept, the Y test that we kept that should be the true answer, and the prediction the machine just gave. So that's how we get our prediction. That's how we evaluate. Are we together? Did you get it? Okay. Uh those online, are we still together? Okay, let me be sure we are together. And are we getting it? You are not. Hey, trust. Why now? I'm not together. Ask your question. What's the problem? But we are running out of time. So let's just finish this. We can always talk. We can always talk. Okay. Okay. So this is the confusion matrix. Not purchase 52. Purchased. So we have the false. We have the true false. How do you call it? True negative, true positive, false negative, false positive. So they should be along this line. So this is what it's telling us. Told us that when it's not purchased, when it's actually not purchased, give the truth, the actual value. Are you getting me? When it's actually not purchased, and at the same time, the machine pretended not purchased, we have 52 instances. The truth here is that it is purchased. The machine predicted not purchased. So this is false. Now, the machine did not predict anything here, neither here. So the machine only predicted for non purchase, so it did not predict any value for purchase. This was caused by what? By the imbalance. It lent more with what you have more not purchased. So that is why it's very, very important for us to balance our data. So that our machine is not thinking it is a norm. Everybody is doing it. So machine still learns that. It's funny, right? Yeah, that's it. So machine still learns that. No, now everybody do so. Everybody is purchasing. That's just money is purchasing. So that's just it. So this is let me read the interpretation here. So here we have 52 true negative. No, our negative here is because it's not purchased, right? It is true because it's actually the true prediction. Good. So predicting that the customer will not buy the insurance, and truly the customer did not buy the insurance. And now we have 28 false negative. It's a false prediction. It's for the negative part which is not purchased. Are you getting it? Okay, good. So predicting that the customer will not buy the insurance, and the customer actually bought the insurance. Now let me ask you, if this one is true negative and this is false negative, now let me show you this again. This question is very logical. This is true negative, right? This is false negative. Then what is this? This box is what? Online, okay. You contribute. You need your contribution here. Okay. Oh yeah, now okay. Aloma, want to say something? Say what you want to say now. Don't be afraid. Fear not. Okay. False, false negative. Okay, and we false positive. False. It can't be false now. This is true negative. This is false negative. If this is false positive, right? No, false. If this is what? Yeah, this cosine. What do you call it? This is true negative. This should be false negative. And now, if this is false positive, then this one should be what? Positive. Let not be confused. So positive and negative here is because not purchased is not a good thing. It's not a good what's it now for the company. That's why we are tagging it negative. Are you getting it? Okay. And then because when you purchase is a positive outcome, right? And that is why we are tagging purchased as positive. So the truth and the false there comes with, is it predicting the right thing? Is the machine predicting the right thing, the right outcome? You are not getting it. I'm confused. It's confusion, man. Okay. Don't be confused. Don't be confused. This is 5 minutes after two. Okay. Now let me explain this and then we close for the we done for today. This is true negative. It is negative because it is not purchased. It is true because uh, the value that the machine predicted but is actually the same with the actual what's now the actual outcome, the expected outcome. Let me use that word. The expected outcome. Are we together? I will explain this in the next 5 minutes and we close. In the next 5 minutes and we close. Okay. That's what are we doing? I don't know. That's this one. Oh, that's just we are friendly. Okay, so that's good collab for you. Now, not purchased is 52. The actual, this means that the actual prediction that was given, the prediction the machine gave after testing with the tests, okay, the prediction and then the outcome and the y test, the actual outcome. We have 52 predictions that were not purchased, that the machine actually gave as not purchased, predicted as not purchased. This is false negative because the machine predicted it as purchased. No, the machine predicted it as, this is false negative, right? Yes, because it is actually not purchased, but the machine predicted what? Purchased. It is not purchased. Machine predicted purchased. It is purchased. It is not purchased. The machine predicted not purchased. Are you getting it? Hello? It is purchased. The machine predicted not purchased. This is not purchased, but the machine also predicted not purchased. So this is correct. This is wrong. Are we together? But not purchased, the actual value, the actual outcome, the expected outcome, not purchased was what the machine predicted. Purchased, the actual outcome, the machine predicted not purchased. Are we together? Hmm? As you come again. Not purchased, this is the confusion. Okay. Not purchased, the actual. We already have our answers. We already have our answers. That was repeated. So we are testing our answer with what was printed by the machine to confirm if the machine actually doing the right thing, if our model actually predicted correctly. So the actual answer, the instances, we have 52 instances when the machine predicted not purchased and it was actually not purchased. We have 28 instances where the machine predicted not purchased, but in real life it is purchased. Yeah, we have zero instances where the machine predicted purchased, but it is what? Not purchased. Yeah, we have zero instances where the machine predicted purchased. Actually, it is purchased. So these are true. All of this. Why? So when you're looking at the diagonal, it is what? True. This diagonal is true. So you look for this diagonal. True diagonal, this diagonal. I mean, yeah, yeah. I get it? True. Why here is not but they are the false. So this is the false negative, this is the false positive. Are we together? Good. So let's continue. So this is the accuracy test. The accuracy is 65% accurate, and then okay, this is a metric classification. Okay, this is a report, metric classification report. This is F1 score. This is a record. This is a precision. These are metrics that we need to also get familiar with. So this precision, this is what precision means. Is in your notes. Please, can you just go through it, and then that's the end of the class. Start for me. No, no, it's okay. It's okay. It's okay. 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 Any question? No question. No question now. Do you have any question? Online, do you have any question? Juni, 65 is not okay. It's not okay. At least we should have 90 and upward. 90 upward is good. 90 upward is good. So we can still tune and do other things to make it better. Okay, but for this class, I think we can stop here. So please don't forget to fill the attendance. Number one, if you are coming here for the first time, review this up. This up is basically so review it. And number do your classwork. Please make sure there are a lot of resources there that is very helpful for you. Okay, so just go there and do that. What again? What do we do to improve model? A lot of things. You can do a lot of things. No, I first said that the model is imbalanced, so you can balance the model. I mean, the data set, you can balance it. Again, you can add more data. You can change your what's this now? The algorithm you use logistic regression, right? So you can use another one. A lot of things that you can do. So thank you very much for your time. We are very happy to have you. So next week we are going to continue with this class. Hope to see you next week. Thank you very much. Okay, so we can continue the discussion on the class on the Google class classroom. Okay, so everyone say okay. So the conclusion: this model has 65% accuracy, which means we need to work more on it to get it to a better accuracy. So we have built a model already, but we just need to increase the accuracy so that it can give us better results. This error. Because of our time, you can just check it online. I don't know where the error is actually coming from. Yes. Okay, thank you everyone. Thank you, Duni. Let me Steve. Thank you, Duni. Thank you, Trust. Thank you, everyone. Everyone, thank you very much. So let's stop. I'm going to stop sharing now, and then we are done with the class.